Okay, this is section 3.3 continued, and we're now going to be looking at the visual method for graphing a line. And so this is the approach that we're going to take the rise over the run, or the change in the vertical to the change in the horizontal. So the first thing that we're going to do is we're going to choose 2 points, and we need integer ordered pairs. We don't want to do fraction to fraction. That's just a nightmare. And then we're going to basically draw a right triangle. So what I'm talking about here is here's a line, here's a point here, and here's a point here. And we're going to get from this point to this point, but we're going to do it like we're in a building. And the only way around in the building is to walk up and down corridors. And so we're going horizontally this way and then using elevators this way. And we're always going to travel in the same direction. So if we're talking about how we get from one person's office to another, this being one office and this being another office. So we're going to move from here by going along the hallway and then up to this office here. Or we could do it from this one. We go down here and across here. Or we could take another hallway, and we could do it in a different manner. We could start here and we could go back this way and then down this way. So that's the right triangle that I'm talking about. And it doesn't matter if we use the one over the line or under the line, although I'll usually do the one underneath the line. And what we'll do is we'll count the number of points that we have to move. So this being our rise, and this being our run moves. And if we move to the right this way, we count them as positive. And if we go to the left this way, it's negative. Rising, if we go up this way, it's positive, and if we go down this way, it's negative. And that's how we're going to make our counts. And then we're going to use the rise over the run and plug in and simplify it as necessary. So with that said, let's go ahead and take a look at this example here. So we're going to find the slope of the line that's shown here by doing the counting method. So I'm going to go from this point up to this point. So I'm going to count my run first, and so I'm going to go over here and I'm going to write down run, just like that. And then I'm also going to write the rise here, and then I'll calculate the slope based upon those two figures. Now, I can't do this within my program over here and have it show up on the screen, but normally when I draw this on the board, I draw in the triangle, and I show the rise written out here and the run written out here, and then I compute the slope. So I'm going to start here, and I'm going to count over 1, 2, 3, 4. So my run is a positive 4 because I've moved to the right 4 spaces. And now I'm going to go up to this one, 1, 2, 3, 4, 5. So I've gone up 5, so that's a positive 5. So my slope, which is the rise over the run, so my rise was positive 5, and my run was positive 4. And of course that's a simplified version of it. So I'm ready to just box it up and say that's my slope, 5/4, 5 to 4. Now you see it doesn't make any difference if I started here and I count back this way, 1, 2, 3, and 4, which would make it a negative 4. And if I have a negative 4 as a rise, or excuse me, as a run, and then from there I go down 1, 2, 3, 4, and 5. So this becomes a negative 5, and then I have a negative 5 over a negative 4, and that of course still simplifies down to 5 over 4, which was exactly the same thing that we saw in our slope formula before, that it doesn't matter which ordered pair you take as x1, y1 and x2, y2, the slope's going to be the same no matter what way we go. And the only difference is the signs of these numbers, but when the signs get simplified, they end up being exactly the same slope. And so now we're going to take a look at a second example, and I want you to go ahead and try that on your own. And then once we come back, then we'll see what that actual example turns out to be. So do this one on your own, see what you get for the slope, and I'll see you in a few minutes.